Well, here on page number 5, we have given that uniform circular motion or magnitude of centripetal force. This is given over here. So, same expression which I have derived, that is given on the textbook here. So, they have considered one object moving in a circle with a constant speed. And we have seen earlier that such a motion is possible only when the object is constantly acted upon by a force directed towards the center of the circle. Means here sun is the center of the circle and earth is the planet. Okay, so this force is called as a centripetal force. That you know very well about the centripetal force now. So m is the mass of the object and v is the speed, then r is the radius of the circle. Then it can be shown that force is equal to F is equal to mv square upon r. And if the planet is revolving around the sun in a circular orbit in uniform circular motion, then centripetal force acting on the planet towards the sun must be F is equal to mv square upon r. Okay, so here m is the mass, v is the speed, and r is the distance from the sun there. Speed, this is the formula for speed. Speed is equal to distance traveled per unit time taken there. So here, the speed of the planet can be expressed in terms of the period of revolution t as follows there. So we have written r is the distance of the planet from the sun. Time taken, that is period of revolution t. Then the distance traveled by the planet in one revolution, that is perimeter of the orbit. That is, perimeter means full circle, one circumference, that is shown here, 2 pi r. So this way, this formula is written. Speed means here v is equal to distance traveled upon time taken, that is distance is circular part, 2 pi r upon time taken is t there. Then force is equal to mv square upon r. Then what is the value of v square? That is 2 pi r upon t, bracket complete bracket whole square upon r, this r as it is written there, right? Then here m is written first here, 2 square is 4, pi square means pi square, and r square means r into r is there here, and this upon r. So this r and this r is get cancelled. We will get simple r here. So we will get 4m pi square r upon t square. We have multiplied and dividing by r square. We will get this equation there. The next term is that this is 4m pi square upon r square. So afterwards we will get this one, r cube upon t square according to Kepler's law. T square upon r cube is equal to k. Okay. Then we will get this next expression there, but this is considered as a constant, and then we will get force is directly proportional to the r square, or force is inversely, not directly, force is inversely proportional to the r square. So what we learn from here, thus Newton concluded that centripetal force, which is the force acting on the planet and is responsible for the circular motion, must be inversely proportional to the square of distance between the planet and the sun. Square of the distance is shown by r square here. So Newton identified this force with the force of gravity and has hence postulated, means he derived the inverse square law of gravitation. So this is called as the inverse square law of gravitation. I told you here, if this you will consider constant, then this is equal to sign will change into the directly proportional, means f is inversely proportional to the r square. So the gravitational force is much weaker than other forces in nature, but it controls the universe and decides its future. This is possible because of the huge masses of the planets, stars, and the other constituent of the universe over there. Now this is next, that is there a gravitational force between two objects on the body, or two objects kept on the table, or between you and your friend sitting next to you? If yes, then why don't the two move towards each other? They are not moving each other because the gravitational force between the two bodies on the earth is not that much stronger. It is quite weak. If it is stronger, no, तो फिर आप एक दूसरे को चिपक जाते थे, फिर that will be the derivation there.